So we do business in about 19 states now and serve around 17% of the population of the U.S., either directly or through relationships we have with other business partners. We operate statewide networks in Indiana, New Hampshire, Alabama, and large regions of other parts of the country that are shown in this little map. So it kind of gives you a little bit of a feeling for what the company's been doing, for those of you that don't know us. A couple of years ago, about 2 years ago now, we started on a couple of different projects. The beginning EZzyNet that we built in Indiana had some unique characteristics in that it was done very early before the NINA standard had been even conceived of. And we had proposed it to the state as part of an RFI process that they had done in 2004, and it kind of took off from there. But along the way, the company's been very active in developing and enacting legislation to try and improve and stabilize funding, and in order to make uniform level of service statewide practical, in order to do transfers within states, between Indiana and all of its bordering states, and as well as improve the quality through improved training and some consolidation of agencies. We had one county in Indiana that it's a fairly large metropolitan area, but it had 18 different PSAPs. They had interoperability only at the call transfer level by admin calls, so no location could be transferred. And so we had a project that did consolidation of the agencies in 2009 to not more than 2 PSAPs per county, and it really was 1 for most. And they weren't defined in the statute. It was very well written, I think, in that it could be a primary and a secondary, it could be a primary and a backup, it could be a primary and a disaster center, and so that brought about a lot of change. But what happened when you do the consolidation is a unit of government may still have special events, those sorts of things that you really need to have a little better routing granularity than just what you get by the square boundary of the county. And so Project 1 was the first attempt that we tried to put in place, which was route by tower. Now, that's obviously being done today through the tabular system, but we thought, well, there were a lot of errors that were in the tabular data. As fast as we could get them corrected, the carriers and their third-party providers could introduce a new set of problems. And so we thought, well, we want something that's more consistent, right? These towers don't move. They're all licensed now. They're all registered with the FCC. That process had worked very well for us with text messaging delivery. We had a very early, one of the first complex statewide text to 911 and text from 911 platforms, and so we thought, well, that's going to be okay. We'll just put a little more code in the cores and the next-gen cores, and I think we can get this thing, off the ground and get it going. Because when you look at what we were trying to solve for, each one of these towers has just 3 sectors. What could possibly go wrong? So we got with one of the carriers and did some testing, and then we put the code in place, and we got going, and we thought, well, this is going to work great, because these were our assumptions, right? Towers are going to have a civil address. There's going to be multiple providers on the same tower. So once you have that sector identified, and the sectors are going to be consistent, there's just no way anything could go wrong with this. We could just take an individual sector, optimize it for what the coverage was for the PSAP. It'd be great. Yeah, okay, well, it wasn't. What we were actually getting through the system as we started to look at it, and this is the Indianapolis metro area, each one of those dots and the size of the dot represents what came in through the alley subsystem as a tower. So we have towers that are somewhere within that circle. Now, for Indianapolis, we weren't trying to do any kind of what I'll call precision routing, because Indianapolis is unique in the U.S. in that the city and the county have this thing called Unigov. There's only one overlying entity for the entire metro region, and it's the, 6th or 7th largest metro center in the U.S. But when we started to look at this, pardon me? Yeah. as soon as we started to look at these long-run studies of what was coming in the alley system, it was just, we were just stunned, because we couldn't understand why you would have a tower have multiple locations. So we thought, well, okay, well, we'll go ahead and let's look a little deeper. Let's look at the phase 2 data and see what's going on with that. And surprisingly, when we started to put this together, you see some pretty interesting trends here, and it's a little difficult to see because there's about 4 years worth of data in this plot. But there are a lot of straight lines coming out of the center of the towers that report to be phase 2 that are not. They're just something, And this was one particular carrier who had a very good high level of accuracy, and they made a corporate change to do something different. And when we looked at their data, and they were one of the bigger, they had a pretty strong market share in this particular region. We were just kind of stunned. So we thought, well, this just can't possibly be happening. Maybe we should do a little deeper analysis into what's coming in the stream. What are we getting in this tower location? And so we pulled several of those, and I've kind of blacked out who the carrier is, but well, this is pretty wacky, because clearly we're not going to have a tower that's at this coordinate set, which is Indianapolis, be in Chicago, but that's the community name that's given in this particular one. This is one of the worst ones that came in. What we concluded was that the third-party provider had a severe database corruption problem, because you have just all kinds of information. Some of these are locations in Indiana, and some are in Chicago. These are at least 200 miles away or more. This is outside of Fort Wayne, and these were all within just a couple of the records. And this was happening to probably about 40% of the records that we were getting in at the time. So if you were trying to display that to the call taker, it did have a 100% confidence rate. So it had to be good. But when you actually looked at what was coming up on the screens, it was easy to see why they were telling us, we just can't rely on this at all. And so we went through and sent, I think we sent back about 600 towers for this one particular carrier, and said, here is what is in the FCC database. We sent them back to the carrier as if we were doing a wireline alley record cleanup, and they handed it off to the third-party provider, and that was after, I don't know, 10 calls or something to try to get the thing fixed. We finally just gave up. So we concluded that this just wasn't, it was a good idea, it just wasn't going to work. And the deeper that we looked into this, it was not just a single carrier. Here's the same tower with identifiable coordinates that are coming in on wireless for phase 1 or phase 2. And this was one of the market areas we were trying to solve the problem for. We had a city within a county that had their own dispatch center, and we were trying to get the calls, in an overflow condition. The policy routing function, we wanted to send them directly to the secondary center to save some time in transfers, because there was some congestion within this particular center at certain times of the day and when certain conditions existed. So what you have is a tower with multiple civic addresses that are coming out, and the sectors are just southeast, southwest. It's all the same. This was all the same sector, by the way. So we concluded at the end of this, our summary for that project was that it was just that was just not doable. There was just no way to route the calls based on the tower information. So project 1, which we thought would come out pretty quickly, which we could use and would be successful, we concluded that was a dud. So then we thought, well, we'll take a little different approach. Why don't we try and go back and see if we can get the phase 2 location information quickly enough from the third-party providers. This is going to be better than the tower because it's going to be the handset. And we can compare that to the tabular data, and then we can make a decision fairly quickly about, which one we think might be more accurate, or we would have the rebid information immediately available to the call taker. We could set the alley system is one thing we have complete control over, because even all of the PSAPs come through an alley subsystem that InDigital operates on behalf of the state, which is how we pull call metrics and resolve problems and do all sorts of things. So even though AT&T or another provider might be the 911 system service provider to the local jurisdiction, it's still queried through our platform, which is an interesting arrangement. I don't think anyone else has been able to duplicate, because we had enough regulatory, mass to get that done. So we wrote a little more code, and we were looking at our phase 2 numbers, and some of them looked really strong. I mean, we had good percentages of the total calls that had them. So we were just really pretty convinced that, some of the PSAPs were saying we're getting, okay, phase 2 data. I think that's good enough for what we need to do. This was still when we were, in between kind of 3G and 4G network phases. Now I'll show you something else. I'll blow your mind later. But we're going to get it pretty quick. Right? We can get that in less than 5 seconds. That's one ringback cycle, and that's about what the CPE is consuming to do the mapping on the CPE. So we've got enough time to get this perfected before it's actually presented to be answered, and the query actually gets refreshed and comes in. Well, that was an even bigger failure than what we had in the first one, because it just, when we looked at the actual numbers when it went into production or into pre-production, we weren't getting in some cases, phase 2 data was taking almost 2 minutes to arrive. In some of these transitional networks between 3 and 4G, what we were getting was really phase 1 data marked as phase 2. It was just a total disaster. It was just a complete, this was even worse than, so we had a meeting, and I thought, look, we've got some of the smartest people that are working on this that are here. We're going to have to try, we have to try something different. Let's see what we can do. And I like this next slide here to kind of show you that this is, in our shop, the result of the smartest minds in the industry. This is our coffee in the break room here. I would like to just point out that the Bunn Corporation of Springfield, Illinois, is not responsible for the coffee pot being left on over the weekend and exploding and setting off the fire alarm system. Even though it says clearly right here, coffee low, empty, turn burner off, it is now, and it's on a timer, which they defeated. So I did question just a little bit whether we really had the smartest people working on this, despite a couple of PhDs and some master's class people there. So anyway, so then I thought, well, maybe what we should do is, instead of trying to go forward with progress, maybe we should just take a look at what's actually happening. Maybe we should look at the data more closely, and that led us to a business relationship with another company who does some very high-end analytics. And so we started to perfect kind of our mapping. And so we knew that we were going to have in this year, this is in the current year, so we've had 2 years of wasted time now on projects. We thought, well, the city of Speedway, which has jurisdiction over the Indy 500 track, approached us and said, we would like to have more of the calls go to our command center and to our facility, as opposed to going to Marion County, because they get overwhelmed in the month of May with the volume of calls. The calls just shoot up. So I said, oh, all right, well, let's try this. Let's get a baseline the month before, and let's see what's actually happening, because where are the calls, where are they coming from in that month before? And so it's probably a little difficult to see from the back, but there's a circle right in here that is the track. It doesn't come through on this too clearly. But what we figured out then was, when we looked at phase 1 and phase 2 call origination, there was still some monkey business going on here in the phase 2 stuff. But this area right along here, there really weren't a lot of calls coming from that area, which is unusual because this is the main grandstand area. So we thought, well, maybe it's just the way the track is used, or, they're all on the golf course that time. I don't know what's going on. So we were trying to kind of sort that out. I circled this in red to make it kind of stand out here, that you can see that we've really got a couple of pretty decent sized towers that are providing the bulk of the service there. Now, keep in mind that this year was the year that 2 competing carriers, the largest 2, both announced they would have 5G coverage for the 500, and they had rolled out extensive 5G networks. And it was, this was from the alley subsystem. Now we do, I mean, you've probably heard me talk at other venues, and we are now incorporating the dispatched address out of CAD as a comparison for many of these to try to figure out what kind of accuracy we're actually getting. But this was just the alley question. So his question was, what was the source? And it was just the alley subsystem. So then we thought, well, we put in place the routing algorithms that we thought they needed. And you can see now, when you look at the month of May, I'm going to put that circle back up here again because the slide dimensions changed a little bit. Huh, that's very interesting. It's very interesting that, and here's the track again, it's very interesting that suddenly we have all of these calls that are originating from these particular locations, and we had people that were working the track. And so when we started to see that come in the first part of the month during the run up to the actual race, we discovered that the cell providers have deployed a huge number of microcells in this area, obviously to carry the traffic. And we really weren't getting phase 2 data that was meaningful. Now the cell coverage was small enough that it was useful enough for dispatch. But we were still kind of, this was about 1,000 calls, which is about 5 times the normal call, about 1,000 calls a month, which was significantly above what they normally do. But we still had some anomalies in this that we couldn't quite get our head wrapped around. But they were pretty happy with it. But what we came away from this deciding was that the connections that we had to the third-party providers, we really questioned if we were on their newest platforms, that maybe there was some refinement that they had made that we had not been made aware of. We had connections to, the usual suspects, I guess I'll say. And we went back to them with this data and said, we think we need to talk about this. And of course, they were very defensive, that claiming our research method was wrong, that only the carriers had access to look at that information. We needed to talk to the carriers. We got all kinds of, we got run around the barn about 5 times. But in the end of that, what we finally decided to do with the two of them, the third one we already had a pretty decent connection from. We weren't having any problem with VoIP originated calls, but we put in brand new connections to their newest, their latest and greatest. We set up closed user groups in the nationwide MPLS networks, and it did significantly improve the performance of the response. We're getting the data back quite a bit faster now. So, whoops. So that's kind of where we thought, well, we're going to try this. So we ended up then rewriting what I like a little bit of our core, which means the whole core, because we were looking at the data pretty intently now, and we had a pretty good idea that if we would make a couple of other changes, particularly to the interface that we were using, to the E2 plus interface, that it could be significantly improved. And there's been quite a bit of turmoil in the industry about whether E2 should be refined or improved, and there's a lot of people that don't want to make any changes to E2 because that's legacy, and there's no reason to improve legacy when you've got next gen, right? So we don't want to do anything to make E2 any better, even though we all know what the problems are and we all know how to fix those problems. Well, we went ahead and did that anyway, and it was kind of interesting. Now, I'm not going to give you a whole bunch of
thousands safe this past weekend. That says a huge number of people traveled to the Terre Haute Regional Airport for the big air show.
Last week, we told you how the Vigo County Dispatch was using new technology inside a mobile command center. News 10's Abby Kirk is live at the Terre Haute Regional Airport. She explains how this system took some of the burden off the normal dispatch center.
Patrice Rondrell, 911 Director Rob McMullen says they expected their phones to blow up this weekend as thousands came into town, and for that reason, he says it was the perfect opportunity to test out this new technology.
It was a busy weekend for thousands attending the Terre Haute Air Show.
And it was a busy weekend for Vigo County Dispatch.
It could not have worked any better.
As call after call came in.
I'm a forward thinker. We like to be top of technology in the county, and we like to have the people looking at us to see how things work.
Rob McMullen is the Vigo County 911 director. He says dispatchers use brand new technology called a geofence.
And we will be using it anytime that we can.
Any calls to 911 from inside the area rang to the mobile command center instead of central dispatch.
All those 911 calls that happen within the fence that we planned there in the airport routed exactly the way they were supposed to, told us exactly where they were out on airport grounds, and it worked flawlessly.
McMullen says they averaged 200 911 calls daily. During the air show, they received about an extra 50 calls over the mobile command center.
People needed assistance with parking, or they had problems with heat exhaustion.
He says several calls were from people frustrated about where to park in backed up traffic.
They were routing people down 46 to the roundabouts and back around to get the flow of traffic off the interstate.
McMullen says several attendees looked to them for guidance. That's why dispatch created an emergency notification system prior to the event.
We had made several keywords for the air show to where we could push alerts and parking alerts and just general alerts and information to the attendees of the air show.
Now, McMullen says nearly 1,700 people subscribe to those text alerts. He wants people to know that you can still receive those text alerts just for weather alerts or general alerts by texting 88777. For now, live reporting.
Let's see if I can get back to mine. So this was an interesting project because for this particular PSAP, this was the first time that they had actually got Indiana DHS to cooperate with them and put a mobile command center in where the 911 center was in the DHS command center. It was interesting because they had about 4 different things going on in the county at that time. They had Indiana State Move-In Day, they had the air show, and they had an ag show. So this is a map of what we actually geofenced. This was, this is high tech here, boy. You can tell we're going to be a GIS company someday, but probably not. We just drew a box, and anything that was inside there, we dipped the record quickly and routed it to this command center. And the command center that they've got down here, we have a little system that we use for disaster recovery and service continuity called MEVO. And we can direct from the cores directly to that. So it's not, it has the functions of a full call processing equipment system. It records the audio and call volumes and all sorts of things. You can see this is how this thing is running. Here's the phone, and it just goes around the back here. This is the DHS one down here. And there's a router here with 2 cell antennas in the back of it on the 2 main carriers for redundancy, and that was how the calls got delivered. And then they had a CAD system, the mobile CAD system we had hooked up to that. So you can sort of see the same things happening here. So I think we finally were successful in kind of cracking the egg, so to speak, in getting the location information fast enough. Now, there were some calls that did not, Rob said it was 100% successful, but there were some calls that, because of the nature of the carriers and some phase 1 data, I would say it was 90%, 95% successful, which was still a big leap forward from what we had done. So I'm kind of happy with this little, improvement that we made to the E2 protocol to get a little bit faster response. The third-party providers were not particularly happy to get it done. They did so under a letter from the governor, which was the only way we could get them to finish the job. But it was, I think it's got some potential. We're not using it in any other jurisdictions yet. Indiana's kind of a science project for many of the things we do, but it was kind of an interesting thing. And I wanted to share that because that was a kind of a big project for us. But really what I wanted, well, we sent a letter to Nina that said this absolutely has to be changed. We think, yeah, Nina's not going to change anything.
So they're actually going to deprecate that
Yeah,
standard and
yeah.
archive it, but it's still an added standard. That's
It
what
is.
it's pointing at.
And the people in Nina are saying, well, we don't want to spend any money on that. So, I wouldn't spend $400 to fix an E2 problem, right? That was the email I just got the other day.
Got it too.
Yeah.
I guess the question is, are you going to make the suggestions up to Addis and the J standard?
I just don't have the political will to do that. The interesting thing about the E2 standard that everybody wants to make the change for is right here. It's for this, because you can't get that information through. And I'm not sure that I think that this is really the big deal. The change that we made was just a very small change in how the initial address packets are assembled, how the initial address headers are done to get faster response out of the system. So, it was a no-cost change, really. It's just a coding error that's been there for 25 years. So, but anyway, let's talk about these for a second. There's a lot of initiatives out there right now to move this forward. Gotta stop clicking my mouse. So AML, Hello, and EED, these are probably some of the oldest ones. Most of you are going to be familiar with these. I did put reference links in here for if you're not, if you get a copy of this. The Hello one was very interesting because we started working with Rapid and Google originally on implementing that in the network in late 2016. That has now evolved. It's kind of morphed a little bit. Apple, when they entered the market, they kind of had to have their own version of that, and so obviously, but it's been interesting to see this kind of move forward. I think the AML side, the what I'll call the European standard, I think that would have some value here in the U.S., but I think its day has kind of passed here. I think the real push right now in terms of deployment is going to be on the other two protocols that the two big behemoths, Google and Apple, have kind of standardized on. This was an initiative that was an Addis FCC initiative, the National Emergency Database. I think I've used slides before that show what 50% of the population looks like. For Indiana, that represents 2 counties, so it's really not going to be very helpful for us. There was also, I think at the time when the NEAD was conceived, it was with the assumption that there would be a merger between Comcast and Time Warner, which of course did not happen. And so a lot of the data is coming out of one of those 2 providers, and now that that's changed to Xfinity and Spectrum, it's been interesting. We have had a very good working relationship with Comcast in a number of markets, in the New England market and the Alabama market. They deliver their calls to us via SIP. So we've got a number of, probably the largest percentage of fixed services that are delivered via SIP today in a couple of the markets that we serve, and they've been very good. Both of them have been. But they rely on vendors in order to do that for them, and there are just limits of what they can do. This is really where the action's at right now, and you've got a lot of activity in the Rapid clearinghouse. The clearinghouse is an interesting thing to me because they have the most valuable piece of information that 911 needs today, the location, and they are telling everyone that they're going to give it to them for free, which I can understand the altruistic nature of that, but I don't know how sustainable a business model that is to pay for the services that are out there. We've had a couple changes in the past couple weeks now that have really made this come alive. We've got a number of agencies that are on platforms that support that, both legacy, what I'll call new legacy, as well as direct interface. iOS 12 came out on the 17th. It was the function was supposed to be in that software update. It kind of was on some classes of devices. Rapid, for their service to work, needs to have iOS 12. This week I pulled a stat from one of the larger companies that we have a relationship with about what the deployment ratio of that is, and it's much higher than I expected, way higher than I expected. 47% of all devices have been updated according to their research, which is a shockingly high number. That means that 12 was adopted at about 4 times the speed of 11. There's only about 7% that are at 10. So if their numbers are right, and they're selling advertising, so I imagine they probably know. That means that and we are seeing this, we're starting to see a lot more handsets now that have that information on a 911 call. The method that we chose to use for this was a little bit interesting. Rapid has custom interfaces they've done deals with a lot of people. and they've done a very good job of that. They're all over the top internet solutions right now. We did an on-net solution for our customers, and it works in two different ways. For some of the CPE, quite a bit of the CPE we support have extended support for the Motorola Vesta platform. It used to be Airbus. They actually, in the current software release, if a customer is on that, they can pull that up down here, clicking this little tab down here that says Enhanced Data. We have an issue, in my mind, about what our company position is that the call taker has got to want to pull that information in, because the FCC has not made it clear that that's the standard yet. So we first push the legacy phase 1, phase 2, and if they want that, they can get it through a couple of different ways. They can either, click the Enhanced Data button, or on some of the other platforms, they can double-click the rebid button within 2 seconds, and then they get the whole display panel changes and they get that information. So native, there's several different ways of doing that. Other mechanisms of doing that are within the mapping that different customers have. DDTI is a GIS company out of Columbus, Ohio that we do quite a bit of work with. They've deployed that extensively in their mapping. They have a direct connection to the clearinghouse. They've done, I think, a very good presentation of how that's done, so it's very clear to the call taker what they're looking at. They do a push, though. They do a query for every record that they get, which is, they're not in the service provider business, so I think their view of the world is we don't have to worry about what the call taker does. We're just delivering it. It's their choice. As a service provider, I've got a little more concerns for liability, so that's why we've been a little more reserved about that. Geocom has a similar arrangement. I didn't put Geocom's up, but they've done a very good job too. Rave had this fairly early, and they, by incorporating it into their platform, Rave Public Safety is a company that makes supplemental personally identifiable information available, and they could mainstream that very quickly because everything is kind of a browser-based platform for them, and so they're doing the same thing. They're showing the Death Star Alley information over here, and then they're giving quite a bit of detail that they're getting from Rapid. I think they've done a very good job. We have a number of agencies who use Rave. Rave has a statewide contract in Michigan where we have a lot of customers, and they did a very quick deployment of that. They've done a very, very good job. This does not, though, get pushed into CAD, which is a big thing for a lot of the agencies. Unless they do a screen scrape, they just can't. They don't get that information. No, it pops on every call now. In the past, it was just popping if there was a record that was built, but so many of I shouldn't say every time, that's not quite true. It's popping about 80% of the time because, as I said, with the 12 deployment to the new version, we're getting big numbers out of this now. And they seem to be, based on this, on what we have done, in the platforms that we've got, and on other testing that we've done, it's sophisticated enough now for retailers who are buying geolocation information from one of multiple sellers that are out there that have enabled their access points in their retail stores to know where you are in the store. I won't name their names, but they have a big red circle. It knows whether I am in the lingerie section or the auto parts section. So we chose to deploy it on our text platform. We're trying to kind of really, kind of focus the company on non-voice communications in more and more ways because it's the go-to solution for butt dial calls. It's the go-to solution for a younger generation of people who think that text is what 911 is going to be about. We do around between 15 and 25,000 outbound text messages in Indiana every month now. So our numbers are really pretty huge. On the inbound side, we're doing between 8 and 10,000 pretty consistently now. That trend is continuing to go up. I should have put a slide in for that. Even in the seasonal downturn of calls, because we have a spike in the summer, text has not had any downturn. It has continued to climb month over month as more people are aware that it's available and as its usage gets significantly better. So we did just a pretty smooth integration of this, I think, into the non-voice platform. So what you're seeing here is what we got from the big red circle is what we got from the carrier. The FF is this is a page out of our user guide and manual for it. But we're getting resolution now from around 1,500 meters down to around 24 meters through the rapid query. And the response is nearly instantaneous. We added a feature which was a kind of a big pull from our agencies. They want us to take the phone number, which I've blacked out here. They want us to query Newstar, or now iConnective, I should be more accurate, and tell them who the owner is, who owns that number. So if we had an agency in Michigan who they had the deployment of some text-based medical alert devices, and they would generate a text call to 911 in the event that the person had fallen or pushed the button. What happened, though, was as the system sends the kickoff message, your call is over, please make a voice call to 911, back to the device, it would then make another call. It would make another text message. So we were in this loop where we had a denial of service, a mini denial of service happening at the agency because we couldn't stop the device from responding to the text message with another message because it didn't get an answer that it was hoping for. So it's kind of interesting, these automated devices. But the agencies have been very happy with this. They can do a query of a voice call through that platform if they have older CPE, or on text, or on our platform it's native. They just go directly there. So you can kind of see that we're starting to get some pretty decent results out of this now. So from our perspective, from our company's perspective, we've been kind of studying this and working on it for about a year. We have the version of TextC deployed throughout the state of Indiana now. We've got about 34 agencies that are up and using that all the time, and we're going to get the rest of the upgrade schedule. I just got in from Alabama early this morning for a rollout that we're doing down there, and you know, it's interesting where you have the different 3G, 4G, 5G networks that you have one common denominator now that's giving, I would say, pretty accurate location information. We're working with a couple of our agencies. We have gotten the line printer feed from their CAD systems, and we're putting that into the analytics platform to try to determine with certainty what did we get from the legacy alley system, what did we get from the clearinghouse, and where did they send the dispatch. So we'll, got to stay on time, but it's been very interesting. So I'll try and take any questions that we've got left, and ran a little long, but get me up afterwards otherwise. Thank you very much. Yeah. Just hit me up afterwards.